Once you get a semi-log paper, just check whether your orientations are right. How? Oh, this is how 5 cycle. Don't take the 4 cycle one, take the 5 cycle. 5 cycle. 1, 2, 3, 4, 5. Okay. How do you check is after 1 it's supposed to be 2. If you made a mistake in the exam, after 1 it cannot be 9, right? Correct now. Okay? Alright. Take the 5 one, remove the 4 one, so the rest sum is 4. Okay. Okay, so once you get this side is magnitude. This side is phase, correct? Okay. You know very well, these two graphs we combine together, right? You know very well. Okay. This is what we call per decade. This is 1 decade, 1 decade, 1 decade, 1 decade, 1 decade. Okay. How do you check where to start your graph? Check both the tables you draw. Yesterday's table, the smallest here is 0.2. Always check phase, because phase we go up to lower, right? 0.2. So you must at least have 0.1 here, correct? Because you know you cannot draw the 0.1. Okay, semi-log paper cannot start with 2, 3 all. It's either 1, 0.1, 0.01, 10, always in 1 only. So if this is 0.1, this is 1, this is 10, this is 100, this is 1000. Are you clear with that? Okay, so you can also start from 0.01, but it's a waste, right? Enough to cover this is enough, because you have to add some more points if you start later, alright? So you do this. Okay, you look at this graph. All of these are actually going down. So you need more space go down than up. Okay, so you know very well, I have done this many times in class. A graph of 30, how does it look like? Constantly 29.5. A graph of j omega, how does it look like? At 1 it is 0, at 0.1 it's supposed to be 20, at 0.01 it's supposed to be 40, it's supposed to go down like that. Then when I combine these two graphs, what happens? At 1 it must be 29.5, at 0.1 it should be 49.5, because 20 plus 29, correct? So this will be, so you know this already. Always at 1 it must take the constant, at 0.1 it'll take the constant plus 20. If it's 0.01 it'll take the constant plus 40. So now I'm starting with 0.1, so I must have 49.5 to start, correct? So I'll start this with 60, 40, 20. So don't change this. Don't change this. This one you can change whether it's 30 or what. But don't change this thing. One small box is 2. This is the best to do. That means this whole big thing is 20. So then you have minus 20, minus 40, minus 60. For today, take this. Tomorrow I'll tell you why when we have extra class. Okay. This is, never. Minus 180. For today, take it. This is phase. Why I'm studying at minus 180. I'll tell you tomorrow why we're doing that. 0, minus 270, minus 360. Okay? Done. You know how we start from. You know how to do. Okay, now you have to draw. At 0.1, what was this combination of both? 49.5, which is somewhere here. Correct? At 1, what's supposed to be with the value? 29.5. So at 1 is 29.5, which is somewhere here. So now you're drawing these two graphs first, because these two graphs doesn't have any corner frequency, right? So you draw these two graphs. Okay, you draw. It's supposed to be this straight line lah, correct? This is what we're drawing. But the thing is, this graph actually changes slope. When does it change slope? At 2, it becomes minus 40. So you draw, but you don't draw fully. You stop at 2. You see, I'm drawing, but I stop at 2. How I know this is 2? Because if this is 1, this 2 will be 2. If this is 10, this 2 will be 20. If this is 100, this 2 will be 200. Understand? So at 2, I stop. Okay, what happens at 2? The slope becomes minus 40. But remember, this is always per decade. So what you have to do, go 1 decade. 1 decade over 2 will be the next 2, correct or not? Okay, now, make sure you go where you stop. Okay, in the exam, you forget to go 1 decade. What happened? You'll be going down. You still cannot draw, so you know something is wrong already. So always go 1 decade first, then go down. Why am I going down? All the slope are minus. If the slope are positive, you go up. Okay, go down. But this is 40. 2 ways to do it. You count 1 by 1 also can. 2, 4, 6. Or, you know this is 20, correct? This is 40, correct? But there's 1.5 box here, so you take out 1.5 box here. Okay? Or you count lah, okay? And then you connect these 2 points. But where are you supposed to stop? Tell me where to stop. Where is it changing? 10. So you connect, but you draw, put these 2 points. But it's just that when you see 10, you stop. Don't look for 10, because then you slope will rally. Correct or not? You connect these 2 points, but when you see 10, you stop. Okay? Okay, then what is the next step? Minus 60. What's my step? Go 1 decade, which is this. Go down, 60. This is 10, 20, 30, 40, 50, 60. 2 box up, 2 box up. Connect these 2 points. Is there anywhere I have to stop? No, right? So you just draw. Straight. Okay. Understand? Okay. If there's possibility the slope go down, same thing. Go up, go per decade, go up, and then connect the points. Same thing. Okay. Are you clear with the magnitude? Okay. How do I start? I check the smallest frequency, and then I always start these two together. Okay. In case you wanted to start more extra. The thing is, you started with 0.01. Started with 0.01. You know at 1 is 29. At 0.1 is 49. At 0.01 will be how much? Remember it's 20, 20, 20, right? 0.01 means it's how much? Okay, at 1 is 29. At 0.1 is 20 more. 49. At 0.01 will be? So if you started with 0.01, you must have more space. But do we need to start at 0.01? No need, because this is 0.2. Why you want to waste so much, right? That's why. Clear with this? Okay, now phase. J omega means it starts at minus 90. Combination of two lah. The 0 minus 90. Where is minus 90 here? So you start at minus 90. You see here, but you still draw from here. But okay, start at 0. But where does it change? 0.2. 0.2 is somewhere here. Okay, now this one for today you accept it. Tomorrow I tell you why we do this. If you realize I've made this upside down. Okay, which means the positive is down, the negative is up. So for phase alone, minus slope goes up, plus slope goes down. Okay, minus slope goes up, plus slope goes down. Okay, now this is 10 boxes is 90 degrees. One box is 9 degrees. So you go 1 decade, same steps, same. 0.2, the next decade is 2. I need, you always see sum, because we already added up. I need 5 boxes up. Why up? It's minus 45, but minus is going up. Why 5? 1 box is 9, 5. So you connect these 2 points, but you stop where? Where is the slope changing? 1. You know, 1. So you connect these 2 points, but you stop at 1. Can you tell me what to do? What do you do at 1? 1, go. Go next decade. Oh, this is no, 1 is here. Anybody see it? 1 is here. Go what next decade? Go up how many? This is 90. 90 will be 10 boxes, which is this is 6, and this is here 10. Connect these 2 points, but where do I stop? Where's the next frequency? 20. So at 20, at 20 you stop. What happens at 20? What am I supposed to do? Go 1 decade, 200. This is 45. Go up 5, correct? Connect these 2 points, but I stop at 100. What happens at 100? No slope. So it's a constant straight line. Are you clear with this? Okay, every time what you do? This one is constantly 90 until the next corner frequency. Go 1 decade, 5 boxes. Connect the 2 points, stop at 1. Go 1 decade. Connect the 2 points, stop at 20. Connect the 2 points, stop at 100. Are you clear? If there was a plus, instead of going down, go up. But it's always 1 decade. That's all. That's about it. The solution of this plot is already in your notes. So please make sure you draw it. Tomorrow's, I'll teach theory first, then I'll also go through if anybody doesn't know how to draw the graph. Okay, before that, if, but we seldom give you a question, if this j omega was not there, that means this thing will not start with a slope, right? It will just start with a... If j omega not there, what happens to the graph? Which is a constant, because now we are combining these two graphs, right? If j omega not there, what happens to the graph? It's just a constant straight line of 29.5. And then it will change. If j omega not there, instead of minus 90, it will start at 0. That's the only difference. Are you clear with that? Okay, go back and draw.